All right. So the first thing I want to kind of go with before we're going to launch in really deep into the electronics part of things is we still have a little bit more to go over. I want to make sure you guys are prepared for lab and you have everything, the tools you need to get finished up in there, as well as just a few other things that we got to cover, kind of first day of class type business. So I've got everything pretty well laid out with how we're going to go through them again today. So we're going to finish up a few things from lab, and then we'll jump into the theory aspect of things. And like I said, if you guys have questions, feel free to raise your hand, ask, and I'll get to your questions, as quick as I can. If I'm not paying attention, I try to explain things and then kind of right over my shoulder, so I'm still talking to you guys. If you can't hear me, please let me know so I can speak up a little bit and make sure I project to the back with these masks on. I am working on printing a mask cover with just a clear face shield so I can stand up here and teach, so it's a little bit easier for you guys to hear and understand me. It's on the printer at home right now, so I just gotta wait for that to finish up and get some other stuff to finish it. So, kind of picking up where we left off, we talked about the syllabus, we talked about where everything is in Moodle. So the next thing we're going to go into is we're going to jump into the handbook, and I just want to cover a couple of things real quick. So you find the handbook by going in through the theory section. This has all the policies and procedures for the College of Technology and specifically for our program. Where did I put it? I swear I had these in order. We'll come back to that. We'll just go in the order I have them. So the safety we're going to talk about first is obviously in the laboratory situation, like we were talking about earlier, you need to be safe. These are going to be some of the questions on the lab safety quiz. It is part of your homework, and so you do need to get 100% on that to be able to turn in your assignments. You can use this. You can use these handouts. You can use your notes. All the quizzes, the homeworks we have designed are supposed to be designed to be open note. Okay, not open neighbor, but open note, open book. Okay, so like we said before, there's no food and drinks in the lab. Please use your own tools. Keep the aisles clear. Do a quick cleanup at the end of the day. Make sure we're not losing components down into the carpet, because we get resistors and stuff into the carpet. They're extremely hard to get out. Adam then has to spend his time on his hands and knees digging them out sometimes with a screwdriver to get them out on the carpet. They get packed in there. It's kind of crazy. So we're talking about violations of the safety things. You need to wear your safety glasses and clothing when you're doing lab, especially when you're soldering. If you're not clipping wires or soldering or things like that, you don't have to wear your safety glasses. But especially when you are soldering, absolutely that's required. And then, when we're dealing with stuff, sometimes when we start playing with capacitors, those are good to have. Wear your safety glasses the first few times, because I guarantee you guys are going to blow them up. It's kind of fun for me because I get to see who's the first person to blow one up. We usually only get about 2 of them, and then everybody's like, "Oh wait, I don't want to do that." So we'll also do some. I'll show you guys when we get to that point. I'll bring them in here and I'll actually blow a couple of them up for you guys, so you can see what happens when they do blow. So like we were saying, is read the MSDS, which is the Materials Safety and Data Sheets. That has been changed to MSD, so Materials Safety Data Sheet. They just kind of combined acronyms and streamlined things a few years ago. That's for stuff like isopropyl alcohol, hydrogen peroxide. Water has an MSDS. That one's actually kind of fun to read if you actually go through. May cause drowning if inhaled. No kidding. But it's actually quite fun. Like I said, if you just look up the MSDS for water, it's really interesting. And because you think about it, it's just water, but it is a chemical. It's a universal solvent. You can use it to dissolve lots of things, sugars, sticky substances. It'll take care of mud. Some things react with water. You put magnesium and water together, you get a small explosion sometimes. Things like that. So always, pay attention with new things that you're using, new chemicals, things like that. Understand how to safely handle them, how to store them. If they're flammable or not. Does a spark cause a fireball? I've seen that before too. Also, one of the things you also be careful with is make sure the equipment you're using has, if it's suspected to be a chemical, this is kind of a good rule of thumb. Make sure it's decontaminated before you start messing around with it. My job again before, I'm going to tell you guys all the dirty laundry that I had up there. But there was one time I had this little pump that it was used to take computer chips after they'd been made to take them back apart. So it put nitric acid on it to dissolve the plastic covering on it so they could get down to the actual chip inside. Well, I was messing with it, didn't completely decontaminate it. It sprayed, went down the front of my shirt, and ate the front of my shirt from the nitric acid. I looked down one day and I saw these spots growing. I was like, oh crap. So luckily I didn't get any chemical burns or anything, but I could have. It was bad. Alrighty. Let's see, what was your name again? Spencer. And what's your brother's name? Reed. Okay. Do not fix, introduce failures, or interfere in any way with another student's experiment. Please don't. Just leave it alone. It's not yours. You're going to have enough failures on your own. You don't need somebody else to mess with it. It happens. Just leave things alone. If you're going to help them, by all means, if they let you and they're with you, go ahead. But don't just mess with somebody's. I'm not going to go through and mess with yours either, because I know how frustrating it can be sometimes. Like we said, know the locations of the fire extinguishers and how to operate them. Most of them, you pull a pin, you squeeze the handle, and you spray. Okay? The pass. The fire extinguishers that we have in the building are rated for electrical. Just so you guys are aware, there's different types of fire extinguishers. We'll actually talk about those here in a minute. Which fire extinguisher can you use for what? All the ones that we have are rated for electrical fires. Know the location of all the power switches and electrical breakers. So the breakers are over here on the wall. The switches are on the front of the thing, and I actually think I forgot that, so that's on me. I forgot to shut the power off before we left. At the end of the day, we'll just make sure we shut our benches off. That way, in case there is something on overnight or whatever. If there's times where we need them on, sometimes in third semester, I know one of them, your power supply is going to be tested that way. You actually turn your power supply on, set it for the voltage, and it puts it under load, and it has to run for 30 hours without burning up. And you'd actually be surprised sometimes how hard that is to do. You will get components that blow, you short circuit something, things like that. Lab benches and stools are not designed to stand on them. Be aware of the evac route, which we've talked about. Just to get out to the building, we'll meet out here on the grass between the road and this building. That's our designated meeting point. If and when we're in class, that's where we're going to go. If it's outside of class, obviously I won't expect you guys to meet there if you're not in this building. So it's just in this time in your building and just when you're in class. Because right now you shouldn't be in the building when you're not in class anyway. We don't have any places for you guys to sit and meet and whatnot. So just keep that in mind. Don't remove any of the equipment from the benches. Remember, you guys have signed everything out with your serial numbers already. So this is just to track it, to find out if we have faulty equipment, where is it going, who's breaking it, why is it getting broken, things like that. We're using it to track and keep track of the information and to be able to provide you with the proper equipment. Be gentle. Some of this equipment is old. Don't force it unless, obviously, I tell you sometimes you have to force it. There are some things, but generally don't force it. Don't just shove random things into power supplies. Don't shove capacitors across the terminals. Granted, that's what I'm going to be doing shortly, but just this kind of stuff on a day-to-day basis. Don't be shoving wires and paper clips and stuff in the electrical sockets. You will get shocked. My kid tried to do that a few weeks ago. They were like, "Oh, look at this," because they're seeing all these electrical things. They ran over with the knife and tried to shove it into the socket. Part of me wanted to let it happen, but I've seen enough stuff that I was like, I can't be that mean. Read the operator's manuals. Don't twist a knob or push a button unless you're confident in what's going to happen. The scopes is not too big of a problem. If you screw up the settings, we can always reset them to default, and you're going to be doing that anyway. There's times something gets screwy in the settings and you're not sure where it went. Just reset to the default, and most of the time your waveform comes back. If we do determine that a piece of equipment is defective, we will tag it out. We'll get you a new one. We'll get it checked, the other one checked in, and another one issued to you. We do have some spares. Most of the time, and not to pick on you guys, it's operator error for why it's not working. But that's why you guys are here, is to learn. So if I tell you it's your fault, don't be offended by it. I am trying to teach you guys and just to show you what you did wrong, not necessarily to pick on you. If it ever does feel like I'm picking on you, please let me know, because I do not want that to happen. That's not who I am. I don't enjoy picking on people. Meanly, anyway. I'll pick on you to have fun with you, but I won't do it to be mean. Make sure you turn off your test equipment, clear your benches, put everything back in your drawer so we can come through and sanitize the lab at the end of the day. If you're going to be away for a certain amount of time on some of the older scopes, make sure you turn the brightness down. Otherwise, it will burn, or it can burn the trace into the screen. So that's what you would see. And then make sure you're using things for the proper ranges. We don't want you guys to be blowing fuses, blowing caps, that kind of stuff. Like I said, most of the experiments are be completed individually. You can talk about ideas, but just directly sharing answers is against what we're trying to do. We're trying to get you guys to understand and know this material so you can do it, because you'll be the ones doing this out in the field when you get a job. The teamwork assignments depend on each member. You know, there'll be times I will, because I'll get to know you guys and you'll get to know me, and we'll find out who's working hard, who doesn't, who complements each other, and those types of decisions will be made in conjunction if we do teamwork on these guys. So at the end of that, we do have these safety regulations, saying you've gone through them. I will show you where these are all here in just a minute. I moved them all to a digital format, so we don't have to sign all these, and I don't have to keep track of 9 billion papers. It's all done electronically. Okay, so that's kind of our first set of the safety, kind of the overview. This gets into the very specifics of some of the stuff we will be dealing with here in class. So here's some of these terms. I'm going to let you guys go through them, some of yourself. We get through them. We have safety, accident, first aid, electrical shock. So this is what I was saying to her. This is when you pass an electrical current through your body, you receive a shock. I mean, that should be a no-brainer. If you've ever taken a 9-volt battery and touched it to your tongue to see if it still works, not the recommended way to check to see if it's a good battery or not. Everybody does it, but you're getting an electrical shock at that time. And if you do hold that battery on there for too long, it can and will burn your tongue. So just fair warning. Conductive materials at which electrical currents flow easily: copper, silver, gold, aluminum, those types of things. And you'll become more and more familiar with these different types of materials, what actually works, what doesn't, what can I get away with if I don't want flow. Sometimes you'll need to short it, and you'll use simply a piece of paper can work. Overloads, what happens if you overload it. Hope you guys know what a smoke alarm is. So this one over here, we have electrical shocks, burns, fires. These can happen, based on what you guys are doing. Anybody can get an electrical shock. A burn happens when you get a lot more current. Like I said, if you hold the 9-volt on too long, it will burn your tongue. And sometimes these burns, you may not be able to see. You can get burns that go through your skin that are now underneath the skin layer, and you can't see them. They do have some of those artworks that I kind of like, the electrolysis. They take the piece of wood, they put 2 great big nails on the side and hook up like a car charging port or something like that, high current, and you can see the electricity burning through the wood. That's what it does to your body as well. It's going to take the path of least resistance. It's going to find those little things, and it's in your, those are going to see those burns and look like that. High current, basically this is kind of what causes some problems. 1 milliamp is what we're going to talk about, is 1,000th of an amp, so 0.001 of an amp, can cause mild sensation or a slight shock. 10 milliamps, you lose muscle control, and you may not be able to let go of the conductor because it'll grab hold of it, and then you physically can't let go, and so then you're going to continually get shocked. 0.1 amp is fatal if it goes through your heart. So 100 milliamps, I misspoke earlier. So 100 milliamps can kill you if it goes across your heart. One of the cool things here is your human body. If you were to take your DMMs, set it to resistance, you can actually put your fingers on it, and it can tell you your body resistance at that point in time. And they should be, 50,000 or 500,000 ohms or more, somewhere in that range. That's just kind of an average. The second you get wet, it drops instantly to 300 or less. So that's why when you get wet, and like in a lightning storm and things like that, or if you're standing in a puddle and you touch a socket, you're going to get an even more of a shock because you have less resistance. And we'll talk about these relationships here next day or two. And so because of that, voltage as low as 30 volts can be fatal. You can use 30 volts. You can use 5 volts and get 300 milliamps out of it. So just be aware. High frequencies. So the higher the frequency you get, that's when you start getting into radio waves, microwaves, X-rays, gamma rays, radioactive waves. We're going to be dealing with frequencies, but not necessarily in those high realms. The chance of exposure is fairly low unless you're building an antenna, screwing around, that kind of stuff. But all the stuff that we're going to do is, you're going to be fine. You don't have to worry about being poisoned from these waves that we're dealing with. Okay. So basically, here's how you treat a victim of shock. Obviously, if somebody gets electrocuted or, things like that, just kind of have an idea of what's going on in case you're around and nobody else is, just to understand what you're working with, and so you can recognize the signs if it was to happen in class. Has yet to happen. We're not gonna plan on it happening, but just so you guys are aware, we do have what to do with if you see somebody that gets shocked. I don't expect you to memorize those, because if we always have this document, you can pull it up and look at it. What do I need to do? Types of fires. This is important. So we have right here, we have 4 types of fires listed. There's one more in here that we don't have listed. Does anybody have a guess of what that one is? We got class A, B, C, and D, and I'll give you a clue. It's not E. It's a class K. Any guesses as to what that would be? Not classroom. Kitchen. So there's class K, so it's like greases, fires, because it's kind of a mixture of everything, but it's specifically related to kitchens, because that's where a lot of fires happen, so it has its own class. So anyway, so class A fires is normal, ordinary combustible materials. Wood, paper, rags, things like that. Normal things that you would think of that's going to burst into flames. Class B is flammable liquids, gas, oil, grease, paint, butane, things like that. Class C is our electrical fires. And you'll know when there's an electrical fire. There is a very distinct ozone smell that you'll get if there's been an electrical fire. And it permeates and it stays forever. Same what happens when you pop a capacitor. It's the same type of smell. Class D is combustible metals, powdered aluminum, magnesium, things like that. We have to treat these fires differently based on what type they are. Obviously, for an electrical fire, you don't want to use what? Water. So we've got dry chemical, we've got CO2, we've got different methods to combat different fires. If it's a flammable liquid, what's another one we don't want to use? Water, because the oils and stuff are going to float, and now you got a flaming puddle in the middle of something instead of putting the fire out, which is then going to spread. And that's the problem with grease fires too, is the water lifts it up and then sends it out. So you want to use something else like baking soda or other things to do that. So all water types you can use for Class A fires anyway. These are just the different types of extinguishers that we're going to use. The ones that we have are mostly going to be this dry chemical. They're going to be like an ABC universal one. So a lot of the dry chemicals and stuff will work for any of these fires. Class D are special case ones that require some specialized equipment. And if we have areas where we're going to be using those, we will have that type of extinguisher next to it. Any questions about that? Color coding. So when you go into a business, either going on a tour or first day of work, and even in our lab, we are supposed to follow this color coding system. This is a generic, nation, worldwide, standardized system of color coding things. If it's green, it's non-hazardous parts. So it's place that you can touch, you can be safe, things like that. Green is good. Yellow is hazardous. So it's like a caution thing. Stairs, ladders, things like that, you're going to see yellow markings. Orange is electrical. Red is places for denoting emergency type situations. Emergency off should be red. Firefighting areas, fire extinguishers, that type of stuff is red. Red is like an immediate danger, emergency type stuff. Blue is things that are out of service and should not be used. And then an ivory is just kind of unable to, to where you can list an edge, like white tape or whatever. So just to give it a contrast to the normal background material and metal and things like that, just to have a visual indicator of where you need to go. So general lab keeping, again, like we said, Do not remove safety devices. Report all accidents. Really, if you cut your finger because you stabbed it with a resistor, that happens. Just let us know. We just need to be aware of it, especially if it's something simple. But if it's something big, obviously, please let me know, because then if there's something big, we need to fix it. Obviously, we didn't have safeguards in place, or they weren't being followed. So please, please, please report all accidents. Clean up any kind of spills. Hopefully we don't have any in the lab. There should be fairly easy. We do have a station that does have alcohol at it. If it spills, please let us know. We want to get it cleaned up immediately. So personal safety rules: secure loose clothing, tie your hair back when you're working on rotating machinery or electrical components. If your hair's flowing down in your face when you're over your circuit board, your hair's going to get caught in the components and it could short something out. I would hate to have somebody get shocked, especially in their head, because their hair, or even just, your hair came down and you had a clip or something in it and it fell out into your circuit board. Now that then just shorted everything out. So just keep everything tied back out of the way. Keep your workspace free so you can move around and not get anything in your way. Let's see, when you're measuring voltages with a meter, be careful not to connect yourself to the voltage and value. It may seem like a dumb thing to do, but there's times where you'd grab onto something. As you're grabbing onto your meter, you've now made a circuit connection between those two contact points. So just be aware with where you're putting things. Don't screw around. Wear gloves and goggles when needed. Don't wear rings or jewelry when working on mechanical, electrical things. The stuff we're going to be doing on it's not going to be too bad, but just as a word of wise, when we start getting into the AC portions, if you're wearing rings, stuff like that, I'd probably take them off, set them to the side, or put them in your pocket just while your hands are in the middle of your circuit. It's just safer that way. Exercise good common sense and good judgment. Common sense things: don't use needle nose pliers as a wrench. We have wrenches. Those, they will break. They could fly off, stab yourself in the face. I've seen it done so many times, especially when I was at ON. There'd be times where people would be using screwdrivers and things in ways that they weren't supposed to. They'd be using it as a pry bar. And I've seen one, it jumped off where they were doing and it stabbed themselves in the arm. So just like, it could have been avoided. We don't want you guys to get hurt. Plus, we don't want your tools or the equipment to break. Make sure you use the right type of screwdriver. If it's a Phillips, use a Phillips. If it's a flathead, use a flathead. If it's a star bit, use a star bit. That's another thing that you can do, is you can strip out parts, and then the next person coming behind you won't be able to get in or out of what you just stripped. And then it makes the work 10 times longer and harder to do the job. That was another common problem we had. People would come through, over-tighten the crap out of stuff with nuts and round off all the nut edges. You couldn't get a wrench back on it. We'd have to go through, grind it, and cut it off, and then refabricate the piece, because we usually damaged it trying to get the bolt out. So be aware of that. Use the right tools for the right job. If you're using things with a cord, make sure you pay attention to where's the work area, where's my cord. Is there any way they can get intercrossed? My dad was using my power saw a while ago, wasn't paying attention, cut the board, didn't realize the cord was right there, and went, cut right through the cord. So not only did he get a nasty scare, he blew out a big old chunk on my saw blade, but it could have been worse for him too. It did short everything out, but it did have some bad reactions. He just wasn't paying attention. So now my cord has been spliced back together and it looks like garbage, but it is what it is. Make sure your hands are dry before using tools. Whether you've used hand sanitizer, if you're rubbing alcohol, cleaning up things, went to the bathroom, whatever, make sure your hands are dry. Don't overload outlets. Don't be plugging things in just to give you more pigtails. Don't go from a 2 to a 4 and then use every single one at the same time. It looks like we have that in the lab, but we do have those rated for higher current loads, as well as not everything's going to be plugged in at the same time. Be conscientious of that. Yeah, so that's kind of it. Like I said, go back through, reread those. I just wanted to cover them very quickly, hit some of the highlights of that. Any questions about safety? Okay. All right, I did have the tab open, I just had it in the wrong place. So this is our handbook for the students, for the College of Technology, and specifically for us. In here is our table of contents. I do want you guys to go home, read this, make sure you understand what's going on. If you have questions, we now have things for the cloth faith coverings. We have the schedule. We have health and safety. We have when we're going to be in class, when we're going to be out of class. Just so you guys are aware, the full semester will end the week of Thanksgiving. Wednesday on that week will be our last day of class, in-person class. After that, you'll go home, go Thanksgiving break. You will not come back to ISU. Finals will be done online, cross campus. Ours is already that way, so it's not too big of an issue, but just so you guys know, that's going to be the last day of in-class work. The 23rd of November, I think. Let me look. 25th, sorry. Anyway, all that information's in here. It's on the webpage for ISU and things like that. And as things keep coming up, we'll remind you of all those things. Some of the things we need to talk about is this one. Face coverings are mandatory. Make sure you take it home, wash it. You know, if you have these. There are ways that the students, you guys can get masks. I'm not sure if they're exactly like this style, but they are giving them to ISU students. You have to go in and check them out or take your student ID, and I believe I'll get the email here in a second to show the locations of those. You just go over there, show them your Bengal ID, and they'll give you a face mask. That way you don't have to wear the disposal ones. You can have the ones you can wash and whatnot. You can wear this style. You can wear the bandana style. You just have to have some sort of a face covering. Face shields don't count unless you're an instructor up here teaching in that moment. That's the only time when you can use like a plastic face shield versus the mask. And like I said, I plan on doing it just because up here walking and talking and stuff, it gets quite hot. Mouth and nose need to be covered. Things like that. Just, you know, pay attention to those. Here is the attendance policy. So for the full semester, which ours is going to be a little bit different than that, these are the absences you are allowed in class without having any major repercussions to your grade. Normally for 5 times you get 5 absences and you get a 2% off your total grade for every absence after that. So if you miss 6 days, that's 2% off your final grade. If you miss 5 or 7 days, that's 4% off your thing. So for us, we fall right in line with this 3-week because we split it up into 2 semesters in our semester. So you have 3 absences per 8 weeks that you can be gone. So you actually kind of get an extra day in between there versus the people who have just 5 days a week. So you have 3 absences between now and the 2nd week of October, and 3 absences from then till the end of the school year. Otherwise, it's going to be the 3% penalty after 3. So if you are going to be absent, come talk to me. There's usually times we can work things out a little bit. One of the things too is especially if you're out for being sick, we have online options available. So if you go home sick and you're still able to attend class by watching it online and completing the assignments, I won't count that necessarily against you. Okay. But if you're just gone, especially if you're just gone and I don't have anything, I don't have any choice. I have to record it as an absence. Okay. Tardies, if you're arrive late more than 10 minutes after we start, or if you leave 10 minutes early, it can be counted as a tardy. Obviously, if there's something that comes up, please talk to me. I am flexible with working with you guys as much as I can. 2 tardies will be the equivalent of 1 absence. So just be aware of that as well. Tardies can get you in trouble. We've had students that have not passed because they were consistently late to class or consistently late to lab or things like that. Those penalties can add up pretty quick. 3 absences right over top of the allowed is a letter grade that you just lost. So just be aware of that. It's really important to be here. This is one of the biggest things that a lot of the companies want to get you guys to understand. You have to be here. You have to be at work. You have to show up on time. Otherwise, you're not going to have a job. And so that's what we're trying to train you guys now for, is to get you into this habit. Obviously, there's exceptions. If you feel you have an exception, please come talk to me. I know some people are involved in sports, school excused absences, things like that. Talk to me beforehand. It's much easier to make sure you're up on everything and you can watch the videos later than it is to make up work. Make sense? Grading. This is going to be the breakdown of how grades are going to go. A minus, B plus, B minus, those. Your grade falls into that range, that's going to be the grade you receive. And this is what I use as my standard. Most of the college uses something similar to this. Some teachers change it a little bit. I had one professor who changed everything so the below 50%, that range, he changed it. So if you get 50% of the material right, that's a C. That's an average grade. So yeah, it was the philosophy class, and I think he kind of wanted somebody to challenge him on that. But that was his grading. So if you got over a 50% in that class, you got a C. It was an odd class, but I enjoyed it. So that's how the grading is going to be. All the grading will be done in Moodle. You can see where you're standing at. You can go in and check with everything that's been graded. I believe Moodle will give you a course total, like a current total. So barring any assignments that you've just gotten a 0 on, if it hasn't been graded or attempted yet, it will give you where you're currently at that moment. If not, I'll show you guys how you can figure that out for yourselves. Moodle, it's weird. Sometimes it works, sometimes it doesn't. It's not the best program, but it works great. Any questions about grading? Okay. Again, at the bottom, go through this, read. Those were the big important parts I wanted to read. The very things at the end are the acknowledgement forms. You do not have to fill those out and turn those in. I have them on Moodle that you'll do electronically, which counts just as much as if you were to sign it and hand it to me, just so you're aware. It's the same acknowledgement, same release. All right. That takes care of those. All right, so here is the section. So this gets into the theory portion, is where these are located. So the handbook signature form. I've acknowledged that I've read the program handbook. You agree with that statement or you don't agree with the statement? Okay, the attendance policy. And I do need to change this guy right here. That was based on last year's model. Consent for photographic release. We have a lot of people that come in and take pictures, either for the companies that they're hiring for, because they want to show where they're getting their graduates from. A lot of the promotional materials that we put out is actually of you guys, of the students being taken place. Also, if we're doing lectures and stuff like that where I'm recording, you may get, your face may be recorded in my video, not necessarily to be broadcast to the world, but for that to happen. You still have this choice. If you do not wish to do that, you do not have to. Okay, you can say no, I do not give consent for this. Okay, and we will make sure that that wish is honored. Okay, so please go through and mark which one you'll do. Just yes, I give the consent. Yes, I give the consent, but it has to be blurred, or no, I don't, type of a thing. And on this one, there's no wrong answer. Just so you guys know, if it does come up that you fail the test because of that question, please let me know and I'll get it fixed. I hope I have it set up correctly to where you don't get 0 credit for saying no, you don't give consent when that's a perfectly valid answer. The computing contract, basically saying that you can use the computer, you can use the computers here on campus. There's restrictions what you can and can't do on them, what you can and can't look at, what you can and can't print, those types of things, what you can and can't download. Basically, that you acknowledge that you agree to that statement. If you don't agree to that one, you obviously will not be able to get onto the College of Tech computers. This is so basically this is consent giving us permission to talk to employers about you guys. Not necessarily names and specific grades, but to explain and have them included in, we have this many students. We have this many students who may be female, because there are some employers who, depending on their hiring needs, they prefer female students. There's some employers who prefer people of a certain age. I know there are laws and stuff against that kind of stuff, but sometimes they have internal metrics that they have to kind of work with. And also, this is to give them information. We said, okay, we have 15 students in here. We have 6 of them that are all running in the high 90s. Okay, we would tell them which ones those are, because those are the ones they're going to want to try and recruit first. I'll be honest. The higher grades you have, the better job offer you're going to get. The difference between an A and a C student can be $20,000. Let's put a dollar value to it. It can be $20,000, $30,000 depending on what you start. So that type is the information that we're going to release to them, like when they ask for things like that. And then they also critique us too on, well, you guys said you have people that know what they're talking about, but your graduates don't know jack what's going on. So then we have to talk about those circumstances. And then this is the safety precautions, basically how to use the equipment. As we get to the equipment, I will show you how to use them. There's a lot of stuff that we may or may not use. So as you get to that equipment, I will show you how to do them or to use them safely before I just turn you loose with a power saw if you've never touched a saw before in your life. I've actually had that happen before. I was helping out with one of the robotics teams, and it came down where we were cutting out pieces of plywood to make part of the field, and some of the people that came over had never touched a power saw in their life, and it was intimidating for them. You turn that thing on and start, and it starts cutting up a piece of plywood. They were a little nervous about it, and so we stepped back and we taught them what to do, how to be safe, and after that they're like, oh, this is easy, and they were just cutting everything out left and right. So just know that if you ever have a question about how to use a piece of equipment safely, please let me know. I will address any concerns you have. And I promise I won't make fun of you for it for the rest of your life. Depending on what it is and who you are and how well I know you, I may or may poke fun at you a little bit. So, any questions? Okay, so this is in here in the theory section for you guys to go in and acknowledge. Okay. So next thing I want to do is I want to continue on with our discussion that we were having for lab, to make sure everybody's on the same page, everybody gets going in lab. Today was just kind of an introduction to this is the lab space, this is where you're going to be working, this is how everything's going to kind of work from here on out. I really would like to do my first lab class in class, but it just wasn't possible, so we're learning and changing things up as we go. So when we get into the lab, the first thing you guys are going to start doing is get into your lab book setup. Okay, it's the first section you're going to do. I don't care if you do this or your safety first. Either way, both of you, everybody's kind of done it both. So the idea behind this is how the labs are going to flow. And I'm going to go through how to write it up in your lab book, how to make things look, what we're expecting out of this. So for the lab book setup, you're going to create your title page, your table of contents, your appendices, and get everything going. So on the first page is very, very important. All entries in your lab book should be in pen. Any question as to why? So no one changes them. So you can certify that it is your work. Okay? In the field, in industry, a lot of times you will have some sort of documentation to say this is what I did. Or if you're developing something, you're going to want to have all your notes in there to say, I did this work, I designed this process, this is how it's supposed to go, and you can be confident that it's not going to get changed, or at least you can see if there's been a change made. It's your legal document. There's times where patents have come into question based on somebody's lab book. Somebody had it signed and dated previously than somebody else. Well, you can't get the patent because it's obviously their idea. So these come in handy too. These become a legal document in some cases with those. Now, obviously, in this class, am I going to say you guys are going to come up with the next billion-dollar idea? Maybe. And then you have your documentation for it. So get it right the first time, then we don't have to worry about things. All right, so you're going to go through, create your title page. You're going to list your program, your semester, your name, your contact information. The reason you do that is in case you lose your lab book. You go to the library, you work on it to get caught up or just to make things look good. You leave it there. People can get it back to you at this point because now they have your information. They could call you and say, I have it. They could call me, look me up and call me and say, I have this student, drop it off and get it to you guys. So really the title page is there for you to claim your book but also in case it gets lost. And then the department, college, university, that kind of stuff. So after you have your title page, and I'll show some pictures of examples of what we're doing here. After you've created it, you're going to create your table of contents. You don't necessarily need to leave 4 pages. A page or 2 will be just fine to keep track of it. This is where you're gonna write what lab you start with, the page that it comes on, kind of a real short snippet of what's on those pages, and then when you start the next section, then you're gonna put the new page number. That way we can tell real quickly which page we need to go to. After that, you're gonna go to the back of your book, and you're gonna create your appendices. So you're gonna create Appendix D, where basically this is a place for you to write down formulas that you come across that you're going to use a lot to help you remember. Remember, this lab book is for you to help remember this stuff as well as to show and demonstrate what you've learned. So you have your formulas. On another page, you're going to want to put commonly used schematic symbols. There's another document in the lab that has a list of schematic symbols. Also, as we learn about them, if you want to update them as we go, that's fine too. So there's several standard ones that we're going to use. What's a power supply look like? What's the difference between a DC power supply and an AC power supply in a schematic? Things like that. So after you get that one kind of labeled in, you're going to have your equipment and materials. This section is one that you're basically going to be referencing here on out. So when you're in a different lab, it's going to have a section in there to say, what equipment are you using? You can just simply put, I'm using this piece of equipment, see Appendix B for details. Otherwise, you're going to have to list out, all the serial numbers, that kind of stuff. It's a time-saving device. So you want to be able to have one section that you can reference to and say, this is where the information is there. Because there are some times where serial numbers and stuff comes into question for calibration purposes. So if somebody was able to pick up your lab book and duplicate your efforts and they get wildly different numbers, it could be either A, you did it incorrectly, B, your equipment is not as precise or calibrated as it should be, which in some instances, with patents and things like that, that's really important. If calibrations are not up to date, your results are invalid as far as the scientific community goes. So this is one way. So instead of having to put this information at every single lab, you can just say, I'm using this equipment, and then it's referenced in the back of the book. So that way, if somebody does want to look, they can go. Also, this is where you're going to kind of write yourself a little cheat sheet on how to use the tool. So, give yourself several pages, at least a page per piece of equipment. So you have 4 pieces of equipment. There's 4 pages you should have, one on each of them. The AC generator, the function generator, your DC power supply, and your scope. You can pick one of the scopes. You don't have to do both. And then also you're going to list other things, resistor ratings, that kind of stuff, ranges that it can be, tolerances, that kind of stuff. And then you're going to have one final section. So Appendix A is any amendments or corrections. This is a section in case you screw up something on your lab book. If you screw up something, I don't want you to obliterate it. So you're simply going to draw an X through it, sign and date it saying you acknowledge that it's incorrect, and you can continue on. But if it's like in a previous lab that you've already started, you can then say corrections are in the appendix, and then you link everything over to the appendix page number. So even though you make mistakes, I don't want them obliterated, and that's where this section is from. Big areas of mistake that maybe need a little more explanation as far as why something happened, why you made this mistake, or whatever it may be, can go in here. But generally, corrections you can just put in your lab book as you make them. The only thing I require is you just put a single line through like your section of text or through a section that's like a calculations that are incorrect. Put a line through it or an X, initial it, date it, and then just put a brief explanation as to why it's been crossed out. Could simply be, I used the wrong resistor in my calculations. That's all I'm looking for. Because then you can still go back and be like, oh, I screwed this up once already. What did I do? Oh, I had in my head I was using this and I didn't make this switch. So it's just really, like I said, it's to show your thought process and to show your work. And then the other thing is make sure you get your header. So is there any question about what we're expecting in the lab book? Okay. Let's see. So that's the first lab. The second lab is the safety, which a lot of you guys have been going through. This is for your information. And one of the reasons why we're having you write it down as well is it is important information, but when you look at something, you have a chance of remembering it. I'm trying to remember what they are, but it's not great if you just look at something or listen to something. If you write something down, you are multiple factors higher to understanding what's going on and to remembering it later. So that's why we have this. You look at it, you write it, you answer it, and then we talk about it again. We try to incorporate all the different styles of learning for you guys so that you're going to get bombarded with the same information 2 or 3 times in 2 or 3 different ways. So that way it gets stuck in there. So when you guys see these points, or these things, the checkpoints, this is where you are required to get an instructor sign off on these parts. Now there is a lot of you, so sometimes, I don't want you guys just sitting there waiting. There are some times where you have to wait because you have to get clearance for me to move on to the next part for safety reasons, or also I'm changing design parameters on you. There's a couple of times you're going to get different parameters for things, so you kind of have to. But when you get to these, this is where you literally have to get a check off from me, and I verify that you have things in the right order. Plus, this is a cue for me to help grade your lab books already. If I see any major problems, I'll have you guys go fix those before I give you the sign off. That way, you have a chance of earning full points on your labs. Because I'd rather give you guys plenty of opportunity to fix mistakes, correct issues before it comes time to get the final grade on it. So that's the purpose of these. Any questions about that?
I'm just wondering where the fire alarm is.
Fire alarm closest to us is down these stairs. So you go down the stairs before you go out the door or down the second set, there's a pull station right there. And so I think that's the closest one to us. I believe there's another one in the front of the building as well. And there should be some down that direction over, but to us, that's the closest one. Alrighty, let's see. Okay, so this is kind of going into more examples of how your lab book should look. Like I said, I understand we're still missing lab books. Try and get them here as soon as we can. Like I said, there's in the email I sent you, there is a couple of them that we like to use. They work really, really well for this program. You can get whichever one you want, but it has to follow those requirements. They have to have numbered pages, it has to be permanently bound, and you have to be able to, use it. Because there's one that are just unusable. Do not get a carbon copy one. Those don't work very well. With what we're doing, they smudge a lot. They're really, really hard to use. So try and avoid a carbon copy lab book at all costs. Okay, so as an example, here is how things are supposed to look. Title page, Robotics, Communication Systems, Engineering, Technology across the top. First semester laboratory notebook. What is this being used for? Your name, your address, your phone number, your email. You can put as much of that as you would like. Minimum of a phone number or an email. And again, that's for contact purposes in case something happens to your book, it can get back to you. Prepared for, you're going to put my name instead of Tim. Tim is the second semester instructor. This was just an example that we sent out to the college. He designed it, so we threw his name there. And you can put my email on there as well. It's holybrode at isu.edu. And then down at the bottom, Technical Department, College of Technology, Idaho State University. That, again, is just more information to saying, where does this lab book need to go if it gets lost? Or, not necessarily lost, you take it to a job interview and the employer accidentally takes it home. And they live in Washington. Happened before. They get home and they end up with 16 lab books and they're like, well, crap, where do these all go? Now they got the contact information to send them back. And honestly, if the employer takes your lab book home, that's probably not a bad thing. Okay, table of contents. What you're going to do is you're going to list it. Label it as table of contents. You're going to go down block 1, block 2, block 3. And you don't have to fill those out beforehand. You can fill them up as you go. Part 1, Part 2, Part 3, Part 0, so on and so forth. What is it called? What page does it start on? That's all you have to have in your table of contents is those information. One of the things too that you need to make sure you pay attention to is you need to sign in and out of your lab book. So when you come in for the lab in the morning, sign in with your initials, and the date and time. Then, when you finish a page, this one doesn't have it on here, but when you finish a page, sign and date the page. So it closes that page because it's going to keep a running chronological order of what you did in your lab book. Any questions about the table of contents, signing in and out of your lab book? No. That's a John Doe student. That's what those initials are for. Yes. Yep. It's just record keeping and closing things out. Okay. When you get into the blocks and the actual labs, you're going to list the big overall goal of the lab. Then each of the different parts, you're going to follow these steps again. So part 1 in block 2 is we're talking about series DC resistance, voltages, currents, and powers. Okay? You're going to list your objectives. This is what you're going to be learning. So that way you can come back and look and be like, what was I trying to learn in this lab? Why did my instructor make me do this thing 19 billion times? Okay, just simply write them out. Just write out the objectives. You can put them in your own words if you want, or copy them straight. Then you're going to list the equipment and materials. What did you use to complete this lab? Okay. Then, if you have any major circuits or schematics, you draw them out, or you draw them out as you use them. No. Separate, yeah. So your notes you can just do on regular paper, anything you want. The lab should just be the lab book in this stuff. This is also online too, so you can print it off as well. But yeah, they should be separate as much as possible. Let's see. Then once you get your schematic done, now you're going to write down your procedure. Now this seems kind of silly. You're going to be writing out all these little steps. You can summarize them as much as possible if you want, okay? But you need to list down the steps that you're taking. That way you can go back through later and be like, oh yeah, that's what I was doing. This is what I learned. Explain what it is. You go through your calculations. When you get to an answer, box it so you and I can find it later when we're looking at them again. If you have any space left over, draw a single line through it. And again, if you draw a line through it, initial and date it, and then close out your page with an initial and date. Okay? Continuing on here, you sign in, sign out, all those different, the same procedures we're looking for. So sign in, sign out is what I'm looking for across every single page at least. Box your answers. And then, when you get done to that, you're going to have a part in here, basically explain what you're doing. If you make a mistake, let's say in here, you use the wrong formula, okay? Cross it out with just either one slash or just put an X. I still want to see it. We don't want it obliterated. Initial it, and then right next to it say, I used the wrong formula. Calculations are not correct. Simple. That's all you have to do. And then continue on with the correct formulas. If there's tables, lay them out like that. Try and make them as straight as possible. You don't have to agonize if they're perfectly straight. Most of the lab books do have some lines that you can follow, but don't agonize that these things are not perfectly straight. The most thing is I want to make sure that you can organize the information you're getting. Then, the biggest part, at the end of the block, I want a conclusion. Basically, your conclusion is looking back at your objectives, restating the objective, saying, in this lab, I was supposed to learn how to use the color code for a resistor. I was able to do that. Did I have any problems? What did you learn? What did you like? What did you dislike? Basically, give me a snapshot. Oh, crap. Give me a snapshot of what you did in this lab in your own words. Make sure the objectives that were described at the beginning of the lab, you covered. Even if it's as simply as like, I learned how to tell what a resistor was by its color code. Okay? Things like that. Then at the very end, again, you're going to sign it, date it, and then you're going to finish everything out with that lab finish off the page so you can't add anything else to the lab. Then you're done with that lab. You'll start the next lab on a fresh side of the paper.
So then when you're doing the blocks in the beginning, what would you say is the best way to space that out properly so it's not on the
So where you don't have your blocks right now or your lab book right now, is that what you're asking?
Or I mean, like when you're doing the appendix and you have the blocks, would you like to just leave it contagious length for like? Okay.
Yeah, yeah. So like I said, so you'll have for your appendices, you'll have one page for any formulas. You'll go back a page. This will be like or go like 2 pages back. That'll be your equipment. Another one back will be like schematics, and then 1 page back would be any additional information that you have to add in for like you changed information or whatever, and then you just work backwards in that instance.
And about how many blocks would you have?
A page or 2, and if you don't use the space, you don't use the space. It's not like you're just setting yourself up for some space in case something was to happen. Okay, any questions about that? Okay, with that, we are up to break time. So we've gone through an hour of theory. Like I said, I know there's a lot of information, and I just keep packing it down as tight as I can. But we're getting close to being done with just the dry information, and we'll start in with learning, hopefully here today, if not for sure tomorrow. But go ahead, take a 5-minute break, stretch, get a drink, do what you need to do, and then we will start class back up again here at 2.